All right, today we're going to pull back the curtain on the absolute fundamentals of programming. We're going to break down those core building blocks that make everything from your favorite app to a massive video game actually work. Let's dive right in.
I mean, have you ever really stopped to think about that? You close a game, you come back to it hours later, and boom, your high score is still right there. Or you log into an app, and it greets you by name. How in the world does it know? You know, it kind of feels like magic, but the reality is, it's something incredibly simple and elegant.
And the answer all comes down to this one single concept, the variable. This one idea is really the key to understanding how programs store and manage all kinds of information. You can pretty much think of it as the memory of your program.
So to really get our heads around what a variable is, we're going to use a super simple but really powerful metaphor. So just forget about computers for a second and just think about organizing stuff with boxes.
And that's literally it. A variable is just a container. It's a box in the computer's memory that you give a name to, a label. So you can find it again later. You can put information inside it, you can take information out, or you can even change what's inside. Basically, everything a program remembers is stored in one of these boxes.
Okay, so let's break this box down a little bit, right? Every single variable has these three parts. First, you have the name, that's the label, like, say, player score. Then you've got the value, which is whatever's inside the box, like the number 100. And then you have the type. And the type is all about the rules for the box itself.
All right, so you've got your labeled box. But here's the catch. You can't just toss anything you want in there. Each box is specifically designed for a certain kind of thing. And that, right there, is where data types come in.
Now, these are kind of the most common types of boxes you're going to run into. An int box, that's for whole numbers. A string box is for text. And a bool, that's short for Boolean, well, that's a special little box that can only hold one of two things, true or false. It is perfect for answering any yes or no question you can think of.
And this brings us to a really important rule in languages like C#. They're what we call strongly typed. Honestly, just think of it as a safety feature. The computer enforces a strict rule that you can only put the right kind of data into the right kind of box. This strictness actually prevents a ton of confusing errors down the line, and it even helps the computer run way more efficiently, because it always knows exactly what kind of stuff it's working with.
I mean, just take a look at this example. It makes it super clear. On the left, we're adding two numbers and putting the result in our number box. No problem, that's perfect. But on the right, we're trying to add text to a number. The computer just stops and basically says, whoa, hold on, that doesn't make any sense. Strong typing is what protects us from that exact kind of logical mess.
All right, so we've got our nouns, the variables that are holding all our stuff. But, data just sitting there isn't very useful, is it? We need to do things with it. We need verbs. I absolutely love this quote because it just clicks, Operators are the action words of code. They're the symbols, like plus, minus, or the equal sign, that actually perform operations on our variables. Now, this is maybe the single most important thing to get right early on. When you see a single equal sign in code, you have to kind of retrain your brain. It does not mean two things are equal, like it does in math class. No, it means a sign. It's an instruction. It's telling the computer, hey, take the value on the right and put it into the box on the left.
Yeah, this line of code right here would probably make your old math teacher's eye twitch, but in programming, it's one of the most common things you'll ever see. The computer breaks it down exactly like this. It always looks at the right side first, does that calculation, and then it updates the box on the left with the new value. It's a sequence of actions, not a statement of fact. Okay, so we have our nouns, our variables, and we've got our verbs, our operators. It's time to put them together and start making sentences, or what we call in programming, expressions. So what is an expression? Well, it's basically any chunk of code that the computer can look at and boil down to a single value. So 5 plus 3 is an expression. Even something like player score greater than 100 is an expression. That one results in either true or false. It's how we ask questions and how we perform calculations. And this is where the magic really happens. This is where it all clicks. We're using a variable to store some information, then a comparison operator to ask a question about it, and finally, an assignment operator to update the state of our program based on the answer. This simple, step-by-step logic, that is the absolute essence of programming.
Phew. Okay, so we've covered a ton of ground. But honestly, these concepts are the absolute foundation for everything else you're ever going to learn in programming. So let's just do a really quick recap.
So let's just put it all in one clean table here. The variable is the box. The data type is the rule for what can go in the box.
The operator is the action you perform on what's in the box, and the expression is the full instruction that the computer figures out to get a result.
And you know, that's the real takeaway here. This isn't just about memorizing a bunch of new words. It's about learning a completely new way to think. It's all about breaking down problems into these small, logical, precise steps that a computer can actually understand and follow.
So I'm going to leave you with a little something to chew on. We talked about how data types help prevent errors, which is great, but why do we even need them at all? Why is it so incredibly important to tell the computer that a number is a number and that text is text? The answer to that question reveals a really deep truth about how programs actually work. Thanks for joining me.